Hi, ladies and gentlemen. Notes 4.1 are on modeling quadratic relations. So the first question asks us to plot the points and draw the graph for each of the relations below. So what I want to do first, before I do anything else at all, is I need to make sure right here that I am numbering and labeling my axes. So I always start off by putting x here and y here, and I put x here and I put y here. Okay? And I need to make sure that I am numbering my axes. So I'm going to say each unit is equal to 1, or each line is equal to 1, but I'm not going to label every single one because that's time consuming. So I'm going to label every other one, so that way I don't spend all my time labeling it, and also so I don't crowd my graph either. But we do need to do it on all 4 sections of my axes right here. Okay, and the tick marks aren't absolutely necessary. I just put those there for the first one so you can see how we're labeling it, but for this one over here, the tick marks are not necessary. Okay, so for our first relation, we need to plot out the points -2, -7. That's what this chart is saying. So this means I'm going to go to -2 on the x-axis, or to the left 2, and this means I'm going to go down 7. So -2, -7, here's where my coordinate's going to be. My next coordinate is -1, -4. So I'm going to go to the left 1, and then I'm going to go down 4, and that's where my next coordinate's going to be. The next one is at 0, -1. So I'm going to go nowhere, right or left, and then I'm just going to go down 1. The next one, I'm going to go to 1, 2. So I'm going to go to the right 1 and up 2. And then the last one is 2, 5. So I'm going to go to the right 2 and up 5. And I can tell as I look at this relation right here that this is going to be a line. It's linear. So I would use a straight edge to make sure that my line is as straight as possible. And I'm going to connect all of my dots. So right here, I've connected all of my dots right here. I've gone through all of my dots. But here's the thing. We have to make sure that that line has arrows on both ends. So please make sure that you've put arrows on both ends. And you also have to make sure it goes all the way through your graph. Now for our next graph that we have right here, we're going to do the same thing. The only thing is, before we move on, we have a typo right here. So I just want you guys to fix this 0 right here. This 0 should say -3. So our first coordinate that we see here is -2, 0. So right here, this point right here, it means I'm going to go to the left 2, and I'm not going to go up or down at all. My next coordinate is -1, -3. So I'm going to go to the left 1 and down 3. Okay, my next one is 0, -4. So I'm not going to go right or left at all, and I'm going to go down 4. The next one is 1, -3. So I'm going to go to the right 1 and down 3. Okay, next coordinate is 2, 0. So I'm going to go to the right 2, and I'm going to stay right at 0. Okay, and then my last coordinate that I have here is 3, 5. So that means I'm going to go to the right 3, and I'm going to go up 5. So right 3, up 5, and here's where my coordinate is. And maybe you can gather that if I went the other way, I would go to the left 3 and up 5 as well, because if you notice, our graph here is symmetrical. So this right here, I'm not going to use a ruler because it's going to be a smooth curve. And this right here is our quadratic relation. Okay, so anytime it looks like a U, it means that we have a quadratic relation. It could also be an upside down U as well. Okay, this one, the one done in purple, is called a linear relation, and it's a linear relation because it is a line, and that's what the first 4 letters of linear spell out. Okay, all right, so now we're going to talk about how we can tell the difference between something being linear and something being quadratic. Obviously, if you see it in front of you, you can tell the difference just by how it looks, because if it's linear, it's going to be a straight line. And if it's quadratic, it's going to be something called a parabolic curve. And a parabolic curve will either look like a right side up U or an upside down U. Okay? Now, the equation of a linear function, or a linear relation, excuse me, will always be in the format y equals mx plus b. And I guess I should say most of the time will be in this format. It won't always be in this format, but most of the time it will be in this format. Okay? Which you guys did a lot of stuff on straight lines and linear relationships last year. But something to be aware of is that there's only an x. So here, the x has a power of 1 only. And what I mean by that is right here, if you notice, this is mx to the power of 1. Okay, we don't put the 1 because it's invisible, but it still means that there's a power of 1 right here. So we'll say that there's an invisible 1 right here. Okay. Now for a parabola, or for a quadratic relation, we're going to have it in the format y equals ax squared plus bx plus c. This is one of the formats we're going to see. We're also going to look at another format shortly, later on in this unit. But for right now, we're going to look at it with ax squared plus bx plus c. So if you notice here, we said x has a power of 1. Here, x will have a power of 2. So we'll say x has a power of 2. Okay? The second part we'll fill in a minute. But right now, what I want to do next is I want to fill in our information about what first and second differences are. So for first differences, to find our first differences for evenly spaced x values, we're going to find the difference between consecutive y values. And don't forget, when we're trying to find the difference between two numbers, all we're going to do is subtract. Okay, between consecutive y values. Now, if we want to find second differences, what we're going to do is we are going to determine the differences of or between consecutive first differences, and I'll explain what that means in a minute. Okay, so this is the exact same chart that we had up here. So this first chart that we have on the left side is our linear relationship. So this one right here is going to be our linear relationship. And then this one over here is the exact same chart that we have on the right side over here. This one is our quadratic relationship, and we're going to have to correct our mistake again up here, or my mistake, and fix this please to a -3. So to find first differences, what we're going to do is right here, we're going to, for evenly spaced x values, so our x values are evenly spaced because they're going up by 1s, we're going to find the difference between consecutive y values. So the way I'm going to do this is I'm going to subtract my y values. So I'm going to take -4 and I'm going to subtract -7. Okay, but when I subtract -4 from, if I do -4 minus -7, the double negatives turn into a positive, and -4 plus 7 is +3. Okay, let's do this one over here. I'm going to do -1 minus -4. The double negatives here turn into a positive, so I end up getting -1 plus 4, and if I were to calculate that, I would get 3. Okay, for the next one here, it would be 2 minus -1, which is also 3. And here, when we do this one right here, we do 5 minus 2, which is also 3 again. So if you notice, all of our first differences here end up being the exact same values here. So right here, it's important that we notice that our first differences are the same. So the word we use for the same are constant. They're the same values. Okay? All right, so now let's do the same thing for our quadratic relationship right here. So we're going to find our first differences right here. So here, what I'm going to do is I'm going to do negative 3 minus 0. So I end up getting negative 3. Here, we're going to do negative 4 minus negative 3. Remember, the double negatives turn into a positive, so it's negative 4 plus 3, which is negative 1. Here, I'm going to do negative 3 minus negative 4, and the double negatives here turn into a plus, so I end up getting positive 1. Here, I would do 0 minus negative 3. The double negatives turn into a positive, so I end up getting 0 plus 3 is positive 3. And then lastly, here, I'm going to do 5 minus 0, which is 5. So if you take a look right here, my first differences are not the same. So first differences are not constant. So since they're not constant, let's go ahead and look at our second differences. So we're going to find the differences between the consecutive first differences. So we're going to take the first differences of the first differences essentially. Okay, so here all these values that are circled are my first differences. So I'm going to do negative 1 minus negative 3. The minus and negative turns into a plus, so I get 2. Here I would do 1 minus negative 1. The minus and negative turns into a plus, so I get 2 again. Here, I would do 3 minus 1, so I would get 2. Here, I would do 5 minus 3, and I would also get 2. So if you notice right here, their second differences are constant, okay? And we'll label this one right here as our first differences. So we can say right here that our second differences are constant. So we can make the conclusion that in a linear relation right here, if we have something that's linear, we'll have constant first differences, and that's essentially just the slope of your line. Okay, so right here under linear, we're going to say first differences are constant. And then here for our quadratic, the second differences are going to be constant. So here we'll say second differences are constant. Okay. All right, so now let's get some definitions down on the next page. So for a parabola, right here, we've already talked about what parabolas are, but let's get the definition down for it. It's a symmetrical U-shaped curve. So we'll write this down right here. It's a symmetrical U-shaped curve that can open up or down and it's essentially just a graph of a quadratic relation. So it's either going to look like this or it's going to look like that. Okay? The vertex is going to be the lowest or highest point on a graph. Okay? So it's either going to be the lowest, also known as the minimum point, or the highest, also known as a maximum point, of a parabola. Okay? All right, next vocabulary word that we have here is the axis of symmetry. And the axis of symmetry is just the line, the vertical line, that cuts the parabola in half. It's literally a line of symmetry. Okay, so if you have a parabola that looks like this right here, your axis of symmetry is right here. Okay, and so we'll put this right here. We'll say that this right here is the axis of symmetry. And then this point right here is your vertex right here, which is your minimum or your maximum point. So this point right here is called the vertex. And the axis of symmetry and the vertex will always occur on top of each other. The vertex will always go through, sorry, the axis of symmetry will always go through the vertex, or the vertex will always be on the axis of symmetry. Okay? And then the last thing that we're going to talk about are roots or zeros. And this is where the graph, where the parabola crosses the x-axis. Okay, we'll say it this way, but it's also when the quadratic relation is 0. Okay, all right, so let's take a look at the example that we have here. The first thing that we're going to do is, again, we need to number and label our axes. So I'm going to label this x, label this y, and I'm still going to put 0 in the middle. And this time I'm going to label every third number, again, because I don't want to deal with making my graph too crowded. Okay? Don't forget the left sides are negative, as well as going down is also considered negative. All right, so now I'm given my equation, and I know that this is quadratic because it is in the format y equals ax squared plus bx plus c. So because of that squared here, I've got that squared, I've got that bx right here. I know that this is quadratic, okay? So right here, I need to get my coordinates. When we did this before, we had actual coordinates that we could graph out. Now we don't. But what we can do is we can take any x values we want and we can plug them in to find our corresponding y values. So our first x value that we have here is -5. So every time I see an x, I'm going to replace it with -5. So if my equation says y equals x squared plus 4x plus 3, every time I see an x, I'm going to replace it with the number -5. But I need to make sure that -5 goes inside of brackets so that way my calculator knows that I'm squaring a negative number. Okay, just like when we did standard deviation, anytime we have a number that's negative, it needs to go inside of brackets, okay? So now that I've done that, I'm going to type this into my calculator, okay? So let's open up our calculator and see what we end up getting. So I'm going to type in -5, and I'm going to square it, okay? Plus 4 times -5, okay? Plus 3. And when I do all of that workout right here, sorry about that, if you remember when we squared this right here, we got 25. When I do 4 times -5, I get -20 plus 3. 25 minus 20 is 5 plus 3. That's how we end up getting this 8 right here. So this value is 8, and a coordinate is always x comma y, so that means my coordinate is -5, 8. But here's the thing, I don't want you to spend all of your time plugging this information into your calculator and showing all of this workout. So I want you guys to use Desmos to get these answers, and I'm going to show you how to do that right now. So what you're going to do, and please actually do this while you're watching so that way you can follow along and make sure that you know what you're doing correctly. So I'm going to go to www.desmos.com, and then I'm going to click on Start Graphing. Then I'm going to click right here on Add Item, and I'm going to go to Table. So again, Add Item, and I clicked on Table, okay? And up here, I'm going to delete this x1 right here, and I'm just going to have x, Okay, and I'm going to type in all of the x values that we have here. So I'm going to type in -5, -4, and then after a while Desmos picks up on the pattern, and you just can keep pressing enter until you get to the last number that we need here, which is 1. Okay, then you're going to type in just this x squared plus 4x plus 3 right here in this section right here. So we're going to delete this y1, and we're going to type in x, and then we'll put squared right here. Let me minimize this, sorry. Plus 4x plus 3. And if you notice, our first x value that we see, sorry, our first y value that we see here is 8. So it goes 8, 3, 0, -1, 0, 3, 8. So now we don't have to do all of these calculations over and over and over again. So what I'm going to do is I'm going to move this so I can see this over here, and then I'm going to put this over here, and I'm just going to fill in the numbers that I have right here. So when x is -4, y is 3. When x is -3, y is 0. Then we have -1. Then we have 0. Then we have 3. And then we have 8. Okay? So now that we have all of those values, we can go ahead and write out what our coordinates are. And remember, your coordinate is, I'm just taking my x value followed by my y value. X followed by y. Okay, so if you guys notice right here in Desmos, you can actually see the points that you should end up getting. We're going to graph it out and then compare and see if this is how it should end up looking. So right here, my first coordinate is -5, 8. So that means I go to the left 5, 1, 2, 3, 4, 5, and then I go up 8. Now I don't have enough room, so I'm going to put approximately where I think it should be. So 1, 2, 3, 4, 5, 6, 7, 8. We'll just go up a little bit higher, and that's okay. The next coordinate is -4, 3. So I'm going to go to the left 4 and then up 3, and that's where my coordinate's going to be. The next one, I'm going to go to the left 3 and stay at 0 because it says 0, so I don't go up or down. The next coordinate that I have is -2, -1. Then I have -1, 0, so I'm going to go to the left 1 and stay at 0. Then I have 0, 3, so I'm going to stay at 0 and go up 3. And then lastly, I have 1, 8, so I'm going to go to the right 1 and up 8. 1, 2, 3, 4, 5, 6, 7. Again, it's a little bit off, but that's okay. So now when I compare right here, it looks to be pretty much the same as what Desmos has here. Okay, so I'm going to connect my dots with a nice smooth curve, because that's what a parabola is. That's what a quadratic relationship is, a nice smooth curve. And this right here is my relationship that I have here, this blue graph that I have here. Okay? All right, but now we need to label in all of that information that we talked about right here. So we have our parabola. The next thing I want to do is I want to find out where my vertex is. Well, my vertex is either the maximum point or the minimum point. Because these arrows go up to infinity forever, there is no maximum, so there's only a minimum. So this point right here is going to be my vertex. So my vertex here is the point -2, -1. And it is a minimum. So we'll call this vertex a minimum. Okay? Now we need to draw in our axis of symmetry, and that's the vertical line that cuts the parabola in half. So if I were to look right here, my parabola gets cut in half right here. So I'm going to draw in my axis of symmetry halfway through my parabola. So right here, this is my axis of symmetry. And because it's a vertical line and it cuts through the x-axis at -2, the equation of this line is x equals -2. Okay? And that's really important. We write it as x equals -2. Okay? And then lastly, we need to write what our roots are. Well, our roots are where the parabola crosses the x-axis. It's when the quadratic relation is 0. So if you look right here, we've got y equals 0 here at -3, and then we also have y equals 0 when x is -1. So these two values right here are called our roots, and our roots are -3 and -1. And we use these squiggly brackets here to show that it's a set of answers. We have more than one answer, and we do not write them as coordinates because they're two separate points on our graph. Okay? So now that we've done that, we'll just fill in our information right here, and then we'll be good to go for this video. So here, it asks us to put in our axis of symmetry. Well, we know our axis of symmetry is going to be the line x equals -2. Then we need to fill in what our vertex is, and we figured out our vertex is right here, and it's the point -2, -1, and we also know that it is a minimum because it's the lowest point. Okay? All right, and then lastly, our roots are where it crosses the x-axis, and our roots are at -3 and -1. Okay, and those are our answers to these questions right here. That's it. Let me know if you have any questions, and we'll talk about this stuff when you do your work. Okay, bye.